What happens when there are more than one stereogenic center? Well, enantiomers are mirror images of each other, and you can still have mirror images of molecules with, for example, two stereogenic centers or even more. Clearly, these two molecules are mirror images of each other, thus they are enantiomers. In fact, the first set of enantiomers. They are also optical isomers of each other. This second set of molecules are also mirror images of each other, and thus they are enantiomers. So we have two sets of enantiomers. All four molecules are optical isomers. But do we have any diastereomers? That's to say molecules with the same atoms connected by the same bonds that are also non-superimposable and this is where it makes them different from enantiomers, non-mirror images. It turns out that we have four different pairs that meet those criteria and are thus diastereomers. Epimers vary by just one stereogenic center of the two or more stereogenic centers. Diastereomers differ by one or more, but not all of the two or more stereogenic centers. All the diastereomers here are also epimers. Enantiomers can have one or more stereogenic centers, but in multiple stereogenic centered molecules are opposite at all stereogenic centers. Let's take a look at these molecules from the side. There. Now, if we rotate the 2,3 carbon-carbon bond by 180 degrees, what we achieve is a backbone with a zigzag pattern. Once in the backbone zigzag pattern, we locate the two higher priority substituents on both carbons, in this case hydroxyls. They face either both backwards or both forwards. They're described as syn in italics. But if these same two higher priority substituents are on opposite faces, so one is backwards from the plane of paper or screen and one is forwards, then this relationship is described as anti, again in italics. The substituents being described don't have to be attached to adjacent atoms, so they could be 1,2 as a relationship, as in this case, or 1,3, or 1,4, etc. Masamune in the early 80s came up with these terms, intended only for acyclic systems. But be very careful, as some chemists misuse them in cyclic cases. They are rather useful, as you don't have to inspect a molecule for long to recognize them.